Ladies and gentlemen, now, we will start our sixth lecture of the analyze phase. During the lecture, the following topics will be covered: correlation, regression analysis, and variation analysis. The Pearson correlation coefficient, designated as R, reflects the strength and the direction of the relationship between two variables. R power 2, or R squared, the square of the Pearson correlation coefficient, which tells us the percentage of variation in Y, and is attributable to the independent variable X. R can be positive or negative. Well, R power 2 is always positive. When R equal to -1, this is a perfect negative correlation. When R equal to 0, this is meaning there is no correlation. When R equal to 1, this is a perfect positive correlation. When R is greater than 0.65 or less than -0.65, this is an evidence of strong relationship. Regression analysis is a tool that uses data on relevant variables to develop a prediction equation or model, y equal to f of x. In simple linear regression, a single input variable, x, is used to define or predict a single output, y. The output you will get from the analysis will include the following equation in the form of y is equals to b1 plus b2 times x plus e. b1 is the intercept point on the y-axis. Think of this as the average minimum value of the output of the model. b2 is the constant that tells you how and how much the x variable affects the output. E is the amount of error or noise. To make the simple linear regression in Excel, click Data, then click Data Analysis, then Regression. Enter the input Y range and input X range. Choose the confidence level and the output option, then click OK. Example for the simple linear regression. The graph has been generated with Excel, and it shows how the number of pizza deliveries affected how long customers had to wait. The generated relation is the wait time equal to 32.05 plus 0.5825 times deliveries. This means that, on average, customers have to wait about 32 minutes, even when there are no deliveries in queue, and that each new delivery in queue adds just over half a minute, 0.58 minutes, to the waiting time. R square equal to 94.1%, it means the strength of the relationship between the model and variable deliveries is 94.1%. If there are 30 deliveries in queue, how long a customer will wait? 32.05 plus 0.58 times 30, which equal to 49.5 minutes. Please perform a linear regression between the schedule overrun in percent and the design cycle time in days in order to measure the correlation and find a model to represent the relationship. Please pause the lecture and solve the exercise. By applying the steps of simple linear regression in Excel, as shown before. The output report of Excel includes the following: the R squared, which is 0.9694, adjusted R square, and standard error. It also includes the coefficients of intercept and variable. The coefficients will be used to generate the equation of the model. Y equal to 0.9362 times x plus 7.1132. Using more predictors in the multiple regression often helps to improve the accuracy of the predictor model. Please find the equation in the form y equal to b0 plus b1 times x1 plus b2 times x2 plus b3 times x3. Y is what we are looking to predict. The x's are the input variables, predictors. The b's are constants that we are trying to find. The generated table includes the following: the r-squared, adjusted r-square, and standard error, the coefficient of intercept, and the coefficients of all independent variables. It also includes the p-value of all independent variables. The p-value for each independent variable tests the null hypothesis that the variable has no correlation with dependent variable. If there is no correlation, there is no association between the changes in the independent variable and shifts in dependent variable. How can we perform multiple regression in Excel using Sigma Excel? Click Sigma Excel, then Analyze Statistical Tools, then Regression, then click Multiple Regression. If necessary, click Use Entire Data Table, click Next. Insert numeric response Y, insert continuous predictors X, or categorical predictors X. Press OK. How can we perform multiple regression using Minitab? Click Stat, then Regression, then click Fit Regression Model. Insert response, insert continuous predictors, or categorical predictors. Press OK. Example for multiple regression. An operation manager has determined the following 5 factors to be significant in delivery customers' orders in time: 1. Inventory accuracy, 2. Rate of rework, 3. Employees' productivity, 4. Delay in the reception of customers' orders, and 5. Accurate loading shipments. He collects the sample of 25 days and tabulates the data, as shown in below table. He wants to create a regression model that would help predict on-time delivery based on variation on the independent factors. Using Sigma Excel, the following equation and table have been generated. The generated model is on-time delivery equal to minus 6.8 plus minus 0.159 times inventory plus 0.029 times rework plus 0.391 times productivity plus 5.25e minus 5 times order delay plus 0.84 times loading. Each additional productivity adds 0.39 minutes to on-time delivery. Each additional delay on loading shipment adds 0.84 minutes to on-time delivery. Each additional inventory accuracy subtracts 0.159 minutes from on-time delivery. Order delay do not have any effect on-time order, or that including order delay in the equation is just adding random variation to the model, CP value. R² is the amount of variation, which is equal to 94.8% of the variability in delivery time. In this case, quite a high prediction. R² adjusted is the amount of variation that is explained by the model, which is adjusted for the number of terms in the model and size of the sample. S is the estimate of the standard deviation about the regression model. We want S to be as small as possible. SE coefficient is standard error. This is a measure of how variable estimate is likely to be. To gain 95% confidence intervals of the coefficient, we multiply standard error by 1.96 and add or subtract this from the coefficient. If the loading equal to 0.84 and SE coefficient equal to 0.074. So, the confidence intervals given by 0.84 plus 1.96 times 0.074, which equal to 0.985, and 0.84 minus 1.96 times 0.074, which equal to 0.695. With 5% chance that we are wrong. T is given by coefficient standard error. Value of T isn't very useful on its own, but it does give us P, which is the probability of the result occurring if the real value in the population is 0. If P is less than 0.05, then the term is significant, there is a correlation. If a p-value is greater than 0.10, the term should be removed from the model. A practitioner might leave the term in the model if the p-value is within the gray region between these two probability levels. P-value is greater than 0.05 and is less than 0.10. From the correlation matrix plot, we may state that on-time delivery increases when there's an increasing number of accurate loading. On-time delivery increases when there is an increasing in the productivity, but with low factor. Productivity and inventory appear to be related as well. Order delay appears to have no effect on loading. The growing probability of implementing an improvement plan was carried out in a company of soda. The factory in Santa Maria and distribution centers in Paso Fundo and Santa Cruz do Sul, primarily in 3 sectors: quality control, maintenance, and production. In order to measure the improvement plan, it is necessary to apply the statistical tool that can correlate the dependent and independent variables. Methodologically, samples of a generic product, A, from line 3 were analyzed for 10 days in a row in order to demonstrate the possibility of correlation between loss of gas, which is dependent variable, with the torque and sequence of days, which is independent variables, and through correlation, perform the multiple regression. Please pause the lecture and solve the exercise. The summary output indicates that the R-square equal to 0.806, and it is an indication for a good correlation, and according to the coefficients of the variables, the resultant model will be y equals 4.65 minus 0.063 times x1 plus 0.0114 times x2. However, it is known that p-value is the lowest significance level that leads to the rejection of the null hypothesis. The lower the p-value, the more significant the test. In this case, p equals 0.626 for the torque, that is, p greater than 5%, so it is accepted that null hypothesis does not follow a normal distribution. So, no correlation to this variable. Now, we cancel the torque and make the regression only with the day sequence. It was noticed that there is negative strong correlation with both the combination and day sequence. By performing significant regression to adjust the regression equation, it was found that the f-value, 31.93067, higher for day sequence, and the p-value, 0.000481, is lower in this variable. By analyzing the adjusted R-squared 0.7746, the highest of them is in this variable. Thus, the equation which used to predict the correlation of carbonic gas reduction has been found with R squared, which equal to 0.7997. Y equals 4.79 minus 0.0689 times x1. As machines are used over long periods of time, the output product can get off target. Below is the average value of how much off target the product is getting manufactured as a function of machine use. Off target value as a function of machine use are shown in the table. Regress the data to find when the product will be 2 millimeters off target. Please perform the activity and send your outputs by email for assessment. Please download the PDF file multiple regression case study and perform the required activity. Please send your outputs by email for assessment. Please download from the resources the instructional video for regression using Sigma XL and Minitab, Regression Sigma XL MP4, Regression Minitab MP4. Variations are the differences that occur in products, services, and processes. There are two types of variation. 1. Common causes. Common cause failure is equivalent to noise in the system, and specific actions cannot be made to prevent for the failure. 2. Special causes. Special cause failure is a failure that can be corrected by changing a component or process. To distinguish between common causes and special causes of variation, use display tools that study variation over time, such as run charts and control charts. Common causes is a variation due to random factors that are always present in the process. A process with only common cause variation is said to be in control. Though random, the variation will be stable and predictable with a determined range. An in-control process may still be unacceptable because it has too much variation. To reduce common cause variation is to change the system or redesigning process. Examples for common cause of variations: inappropriate procedures, poor design, poor maintenance of machines, poor working conditions, for example lighting, noise, dirt, temperature, ventilation, substandard, raw materials, quality control error, vibration in industrial processes, ambient temperature and humidity, normal wear and tear, variability in settings, computer response time. Special cause is a variation above and beyond common cause variation, arising from factors that are not always present in the process. Every process has common cause variation, with special cause variation is said to be out of control. Variation from special causes is not random, identifiable patterns, but its impact is unstable and unpredictable. Reduce special cause variation by tracking down and eliminating the specific, assignable root cause, looking for what's different in the process when the special cause variation appears. Examples for special cause of variations: poor adjustment of equipment, operator falls asleep, faulty controllers, machine malfunction, computer crashes, poor batch of raw material, power surges, abnormal traffic, click fraud on web ads, extremely long lab testing turnover time due to switching to a new computer system, operator absent. Please download causes of variation activity.pptx file from resources. Drag and drop every cause of variation under either a common cause or special cause. Send your solution by email for assessment. Thank you, and see you in the next lecture of Analyze phase.